Welcome back to Learn Extra, guys. I am now going to do question 1.2 from GDE paper 2, the preliminary paper, I think it is. And it deals with box and whisker diagrams. Now, what's nice about this question is it doesn't actually ask us to draw the box and whisker diagram, but it asks us to compare different things to compare different box and whisker diagrams. Now, just quickly, a recap for those of you that have forgotten. We use our 5-number summary to draw the box and whisker diagram. The 5 numbers are the lowest number, the highest number, the median, and then Q1 and Q3. So those are the 5 numbers that we use for a box and whisker diagram. Now, our telephone number, 086 1058 262, 086 1058 262. So please call us if you've got a question for us. Let's have a look at this question. The question says, the 3 box and whisker diagrams shown below represent the mass in kilogram of 64 newborn babies, 57 3-month-old babies, and 42 6-month-old babies. So that's the first thing that's quite important, is that the 3 box and whisker diagrams don't represent the same number of babies. Now let's have a look at those babies. Okay, so let's have a look. Here's our newborn babies at the bottom, so 64 newborn babies. Just going to put the numbers next to it. And the 57 and 42. Right. The first question that we are asked, okay, so if we just have a look at the 3 box and whisker diagrams firstly, it actually makes sense that the box and whisker diagram for the newborn babies is more to the left, because here's our scale in kilograms. Obviously, a newborn baby will weigh less than a baby that is 6 months old. So then the 3-month-old babies, and then finally the 6-month-old babies. And the first question that we are asked is, approximately what percentage of newborn babies weigh less than all 3-month-old babies? Okay, approximately what percentage of newborn babies weigh less than the 3-month-old babies? Now, if we have a look here, that is where the 2 almost sort of, that's where the overlap ends. So what's very important with a box and whisker diagram is to remember that because we go from 0 to Q1, Q1 to Q2, Q2 to Q3, and then to the maximum, what we have done is we have divided our data into 4 equal bits. So therefore, this is 25%. That little bit up to the median, which is not so clearly visible, is 25%. There's another 25%. So 75% of newborn babies weigh less than all 3-month-old babies, but there is a 25% scope where newborn babies actually, the top end of the newborn babies are actually within the range of the 3-month-old baby. So I think the most important thing to remember here is that what a box and whisker diagram does is it divides our data into 4 equal pieces, 25%, 25%, 25%, 25%. Now, what I find at my school especially is that if you guys are faced with a box and whisker diagram, like let's look at the first one. Because that line over there is shorter than this line over here, it doesn't make sense to you guys that both represent 25%. But this is how you need to look at it. This is still 25%, but there's just a bigger range between the lowest and the highest in that 25%, and that's why the line is longer. Not because there's more data there, but because the range of the data is wider. Right, let's have a look at the next question. Okay, they say same story for the 3-month-old and babies. Are most 6-month-old babies heavier or lighter than 7.5 kilograms, and explain your answer. So are most 6-month-old babies heavier or lighter than 7.5 kilograms? And explain your answer. Now, just for the 6-month-old, I'm just going to put the median in there because it didn't scan so nicely. Right, now we need to go and we need to have a look at the scale at the bottom. Now, 7.5 kilograms is directly over there. Okay. Now, again, let's talk about the 25%. 25% here, 25% up to my median, 25% and 25%. So if I look at the 7.5 kilogram line, I can see that 25%, 25%, and some change is more than the 7.5 kilogram mark. So yes, it is, and that's because 25% is in the upper quartile, 25% is in the next quartile, and a portion of the second quartile is also above the 7.5 kilogram line. Right, let's have a look at the next question. The next question is, how many newborn babies weigh less than 3 kilograms? How many newborn babies weigh less than 3 kilograms? Okay. So there's 3 kilograms for the newborn babies, and percentage-wise, I can see that 75% of all newborn babies weigh less than 3 kilograms. Now let's just go and have a look again. How many newborn babies did we have? 64. So 75% of 64 is what we need to find out for our next answer, and that's actually quite easy because 64 divided by 4 is 16, so 16 times 3, you can use your calculator, and 48 out of 64 newborn babies then weigh less than 3 kilograms. Right, guys, so this is a nice box and whisker interpretation. It's not a lot of marks, but it's so important that you guys are not fooled by the length of the lines, that you guys see that each of the divisions from minimum to Q1, from Q1 to Q2, Q2 to Q3, and then again to the maximum, the data is divided in quarters. Very, very nice question. Right. Now, remember the number to dial is 086 1058 262. Our email address is helpdesk@learnextra.co.za. So that's helpdesk@learnextra.co.za. You can also go onto Facebook if you've got questions for us. Just remember to include your telephone number. And in the meantime, we're now going to carry on to question 5 on the GDE paper. This is a lovely question. We are told that we are given a circle, x squared plus 4x plus y squared minus 2y equal to 0. Also, we are given the point P, where x is minus 1 and y is 3 on the circle, right? I can see that I've got a tangent drawn over here, and that the tangent intersects the x-axis at R over there. And our first question then, determine the coordinates Q of the center of the circle. So by this time in your matric career, this shouldn't pose too much of a problem. Remember that we've got to get the equation of the circle into standard form. So we've got to complete the square. So let's do that. Right, so I'm going to start off by saying x squared plus 4x. And then I have a look at the coefficient of x. I halve it, I square it, I add it both sides. So a half of 4 is 2, of course, and 2 squared is 4. Right, I'm going to add it in over here because I'm scared I'm going to run out of space. Now I also have to deal with the y's, and I say plus y squared minus 2y And then I have a look at the coefficient of y, which is -2. I halve it, I square it, and I add it both sides. +1 and +1. So now we've completed the square on the circle, and all that's left to do for us is to write it into standard form. So this is x plus 2 squared plus, and then y minus 1 squared, which is equal to 5. Right, so really, guys, you can't even move on a question such as this one if you don't get the equation of the circle into standard form. And now, immediately, there's quite a lot that I can say about this circle. I can say that the center of the circle Q is at -2 and +1. And that's nice and consistent with my diagram. So that's all very nice. And I also know that the radius squared is 5, so that means that the radius is √5. So that was our first question, just to determine the coordinates of Q, the center of the circle. Right, let's have a look at the next question. Now we are asked to determine the length of PQ. Now, guys, please, whatever you do, don't do the distance formula. PQ is a radius. So we already know that the radius squared of the circle is 5, so the length of PQ must be square root of 5 units. And I think it will be absolutely fine to leave it in surd form unless you're told otherwise. Right, so nothing too wildly challenging at this point. I'm just going to fill in the coordinates of the center of the circle again. Right, the next question asks us to determine the equation of the tangent PR to the circle at P. So determine the equation of the tangent. Now, finding the equation of a tangent is also one of those standard things that we should really be able to do in our sleep. So the first thing that we're going to do is we're going to calculate the gradient of the radius. The reason we do this is because we know that at the point of contact, the radius is perpendicular to the tangent, so we can use the gradient of the radius, invert it, and change its sign. So let's get going on that. So I'm going to say 1 minus 3 divided by -2 minus -1. Right. So this gives us, at the top, -2, and at the bottom, -1, which means that the gradient of the radius is 2. Now, whenever you're calculating a gradient, it's very important to keep on looking at your sketch and just make sure that the gradient that you've calculated is actually consistent with your sketch. Because very often we just get into doing all sorts of calculations and we never ever check. Now, I'm going to check quickly, and I'm going to say, right, I have now calculated the gradient of my radius. And the radius is running uphill from left to right, so that does look realistic. What I have calculated is consistent, more or less. Okay, now I have to calculate the gradient of the tangent. Now I'm actually going to put the little r there for radius, and I'm going to say the gradient of the tangent is therefore -1/2. And that is because of the fact that the radius and the tangent are perpendicular to each other at the point of contact. Right, so far so good. Now let's quickly put it into our formula. I'm going to say y minus y1 is equal to the gradient m and then x minus x1. And it's now very important that you remember to substitute the point of contact in. For some reason, sometimes people substitute in the center of the circle. That makes no sense whatsoever because the center of the circle is not on the tangent, right? So we're going to say y minus 3 is equal to negative a half x minus 1, which then becomes x plus 1. And now all that's left for us to do is just to tidy it up. And tidied up, we get y is equal to minus a half x plus 5 over 2. So up to here in this question, you should be sailing. There's nothing interpretive. We're just asking you to do stuff, which hopefully you've practiced quite a lot. So nothing too hectic about this at all. But as with most things, they do eventually get a bit tougher. And let's have a look at what else we can be asked. The next thing that we are asked, it's a lovely question, is to find the size of angle PQR. Now, find the size of angle PQR and round your answer off to 1 decimal. Now, because that line is not drawn, I'm going to draw it. Over there. And we are asked to find PQR. So that's that pink dotted angle over there. Right, now there's a couple of things that we need to think about in this question. And now we're starting to think a little bit more. Already I know that the radius is perpendicular to the tangent at the point of contact. So I can put that 90 degrees in there. In order for me to calculate the size of angle Q, I will now need to calculate that angle over there. And it's not all the way to the x-axis. It's that angle over there. Now, what I'm going to do is I'm going to use angle of inclination, but there's a couple of things that I now need to bear in mind. If I use the gradient, of this line, which I know, the tangent, that's minus a half. That will give me that entire angle, right? So therefore, I can work out this entire angle using angles on a straight line. So that's not what I want. I need to, well, I want that, but I'll also have to calculate the inclination, the gradient of this line. That line over there, I wanted to use a different pen. I'll also have to calculate that and then subtract the two from each other. So there's quite a lot of work to be done over here. So I'm going to start off by calculating the coordinates of point R. Now, point R is the x-intercept of my tangent, and I know that the equation of my tangent is y is equal to minus a half x plus 5 over 2. Now, to get the x-intercept, I'm going to make y 0. Let's move the half x over. And multiplying through by 2, I get that x is equal to 5. So R is the point x is 5 and y is 0. Right. Now, Q I calculated much, much earlier on, and that is negative 2 and 1. And I'm now going to calculate the gradient of that line. Then I'm going to shift tan my gradient so that I can get this little bit of the angle over there. But quite a lot of work, this question. Right. So for my gradient, I'm going to say m equals 1 minus 0 divided by -2 minus 5. So the gradient of this line is -1/7. Right. So now I'm going to take out my calculator and I'm going to say, well, let's clear it first. Right, so I'm going to say second function tan of 1/7. I just want to find my fraction button. There we go. -1/7. I expected that that might happen. I think I need to put some brackets. So let's go shift tan and find a bracket and do a fraction. -1 divided by 7. And let's close our bracket. Okay, guys, I'm not 100% used to working with this calculator, so in the meantime, let's just talk our way through this. So we're going to say shift tan of -1/7. Then that's going to give you a negative answer. What you can then do is just take the positive of that answer. If you wanted that part, you would add 180, but you can literally, alternatively, you can add 180 and then subtract it from 180 again, and that will give you that green portion over here. This green, well, let's make it green, that green portion over there. Then, you know that the tangent's gradient is -1/2. So what you're going to do is you're going to do shift tan of -1/2, and in the same manner, you're going to then get that inclination. What you then need to do is take your second angle and subtract the first angle from it, and that'll give you this little bit over here, and then use the property of the angles of a triangle adding up to 180. So therefore saying, well, that's 90, that part is known, and subtract the 2. Right, so quite a challenging question towards the end, at the end. Pity I couldn't get my calculator to work, but and I didn't bring one into studio, but I'm sure you guys can work through that. Now the number to dial if you've got a question for me is 086 10 58 262. You can also post your questions on Facebook or helpdesk@learnextra.co.za, remembering please to include your telephone number on your emails and your Facebook posts. Right, we're going to take a short break. Right after the break, I'll be back with our next question.